Hey guys, what's up again everybody? Welcome back again to another video from the Apex Academy of Mathematics, where learning the language of the universe begins here. My name is Akin. Now I'll be taking you through the third upload of the January 2021 paper. Alright, do check my playlist below to see the other two uploads before continuing or picking up on this video, and I hope that you're learning something from this content and you are preparing well for your exam. Alright, now without further ado, the last video ended at question 5a part 4. We're just going to pick up at 5b and proceed. This video will be a little bit over an hour long, so let's get settled and try to get in some knowledge and some understanding. Alright, so let's go. Alright, so we're at question 5b here, and this is saying here that a group of students wrote a physics examination. Each of the students achieved a grade 1, 2, 3 or 4. Alright, the pie chart below shows the results. So let's examine the pie chart, guys. This pie chart, in this section, we don't know what the angle is, we don't know how many students, neither do we know the angle for this sector or the angle for this sector. We only know the angle for this sector and how many students it represents. So alright, we're gonna have to do with that. It says here that 39 students achieve a grade 3, which we know here. Our job now is to determine the total number of students who wrote the examination. Alright, now what we can do here, guys, is here's what we're gonna do. Okay, now first thing we need to remember or to note is that total angle, just a second guys. Alright, so what we need to know is that the total angle or the total, okay, I should say the total sum of the angles. So the total sum of the angles in a circle is equal to 360 degrees. So if I could find what's the value of 1 degree, then I can find the value of 360 degrees. Alright, so I'm going to be using a direct proportion method here to help me find the value of 1 degree. We already know that 117 degrees is equal to 39 students. So if I can divide both sides by 39, let's just write that a bit clearer. Alright, we know that 117, let's write deg here, so 117 degree is equal to 39 students. Alright, so if I can just divide both sides by 117 degree, then 1 degree, 1 deg is going to be equal to 39 divided by 117. Alright, now if you want, you could write the decimal form of this, so we could say or 39 divided by 117, and that's going to give me 0.333 recurring. Okay, so if you want, you could use the 39 over 117, or you could use the 0.333. I'm just going to use the 39 over 117. So now that I have the value of 1 degree, then 360 degrees, which would represent the total amount of students that wrote the examination, will be 360 multiplied the value of 1 degree. I'm going to use the 39 over 117. I feel like it's a lot easier to me. Okay, so I'm going to just multiply now by 360, and that will give me the result that 120 students sat this examination. Okay, alright, so that was pretty good, guys. Hope you all got that. Okay, alright, good. So let's go on to the next page. That's for 2 marks. Now we're looking here at ratio. Alright, so the ratio, they have combined a bit of ratio with the pie chart. never seen this combination before, but nevertheless, let's get to it. The ratio of the number of students who achieve grade 1s, 1, 2, or 4 is 2 to 4 to 3. A student passed the examination if he or she achieves a grade 1, 2, or 3. How many students passed the examination? Alright, so the main question is how many students passed the examination, and right here they said that a student passes the examination if he or she achieves a grade 1, 2, or 3. So with this statement right here, and with the question being asked, I can immediately derive a small little formula to help me. So I can say that total number of students who passed the exam, that's going to be equal to grade 1 plus grade 2 plus grade 3. So the ratio, let's look at the ratio, and that's going to be, let's see here, let's do this. We'd have grades 1 to grade 2 to grade 3. Okay, there's no 3, this is 4. Okay, so we're comparing grades 1 to 2 to 4, and the ratio is 2 to 4 to 3. That's the ratio. Alright, so what do we do here now, guys? What information do we have? Alright, now in ratio, one of the things that you need to learn how to one of the first things that you need to do is to find the total proportion. So the total proportion, alright, before we find the total proportion, let's go back to something that we might have done earlier. Alright, so let me take you back a little bit here. Alright, so here we go. We know that the total amount of students in that sit the examination is 120. That's what we know for a fact. Alright, we know that for a fact. So this represents the total proportion, which is whatever the ratio is supposed to be. But we know something from it. We know that the number of persons who got a grade 3 is 39. So what that tells me is that the total amount of students that is represented by the ratio, the total amount of students that is represented by the ratio 2 to 4 to 3 that's going to be equal to 120 minus 39. Right? So that's going to be 120 minus 39, and that's going to give me a total of 81 students. So therefore the total proportion is equal to 2 plus 3, or 2 plus 4 plus 3, and that's equal to 9 parts. And that is the ratio or the rational proportion that represents the amount of students for grades 1, 2, and 3. And since we already, for grades 1, 2, and 4, but since we already know what number of students represents grade 3, we subtract that from the total, so this would represent, this 81 here would represent grades 1, 2, and 4. And we know that the total proportion of parts that represents grades 1, 2, and 4 is 9 parts. So in essence, with all of this being said here, guys, let me just erase here. We know that 9 parts is equal to 81. So we can find one part, and one part is going to be equal to 81 divided by 9, which is equal to 9. So one part is equal to 9. Alright? So therefore, if one part is equal to 9, and we know the individual parts for grades 1, 2, and 4, we won't need to include the part for grade 4 because grade 4 is not a pass. We could simply say that, okay, if one part is equal to 9 students, then two parts would have been equal to 18. Alright, so 18 students would have been for grades 1, simply because that is 2 times 9, 18. And 4 parts would have been equal to grade 2, so 4 times 9, that's going to be equal to 36. Okay, so 2 parts times 1 part, which is 9, that's 18. 4 parts times 9, that's equal to 36. And then we already have what represents grade 3, which earlier we were told that it's 39. So remember, essentially, that what we're looking for is the number of students that pass the examination. And so the number of students who pass the examination would have been grades 1, grades 2, and grades 3. So if we add that total up, then we should be able to get the amount of students who pass the examination. And that's equal to 93 students. So I hope that wasn't a little bit too confusing for you. Let me just do a quick summary on exactly what went down. Alright, just to wrap this all up with what you're seeing on the screen. The first thing that we needed to do was to establish a relationship between the grades. And the relationship that was given to us was the relationship between the grade 1, the grade 2, and the grade 4. We weren't given the relationship or the proportion involving the grade 3. So what we did first of all was find the total proportion, which was 2 plus 4 plus 3, right here. 2 plus 4 plus 3. That represents the amount of parts in which grades 1, the total amount of students grades 1, 2, and 4 represented. Now to find out the amount of students that is in, or that is pooled together to represent the grade 1, 2, and 3, or the grades 1, 2, and 4, we have to subtract the amount of students that got a grade 3 from the total. So we know from over here that 39 students, here, 39 students, which was told to us represents grade 3. So if I subtract this 39 here from the total of 120, then that will tell me how many students represents grades 1, 2, and 4. Now, since I know the amount of parts that represents grades 1, 2, and 4, and I now know how many students represents those 3 sectors, then it simply would tell me that 9 parts, which I had calculated right here, 9 parts, 2 plus 4 plus 3, would represent the amount of students that is in sectors grade 1, grades 2, and grade 4. So by subtracting the 39 away from the 120, I would have gotten 81, so 9 parts would have been equal to 81. So therefore one part, one portion would represent 9 students. Now grade 1 got 2 parts, so that's 2 times 9, 18. Grade 2, 4 parts, 4 times 9 is 36, and we already knew that grades 3 is 39. Because remember, to pass the exam, a student must achieve a grade 1, 2, and 3. So we did involve this 3 here. And that gives us a total of 93. Alright? So I hope that little summary kind of, clear up any misunderstanding that you may have. Feel free to just rewind the video to the part from the beginning and see if you can understand a little bit more. Alright? But we're going to move on to the next question. Alright, so we have to determine the value of the angle for each sector representing grade 1 in the pie chart. Alright, so we know how many students now represents grade 1, which is 18. So that's 18. I will know the total amount of parts. I will know the total amount of students in the survey, so that's 120. And then because the whole entire circle is accumulated to a total of 360 degrees, we're going to multiply that by 360. If they wanted, like, say for example, the percentage of students that represented grade 1, we would have times this by 100, but because we want to know the angle, we're going to times it by 360. So you can use your calculator here all at once. Alright, so you could say 18 divided by 120, and then we're going to multiply that now by 360 degrees, and that should tell us that the angle is equal to 54 degrees. Alright, and that is the angle that represents grade 1. Alright, tricky little question. It's not as straightforward as you think it is. It's a mixture of ratio with the pie chart. Never seen this combination before, but that is Csec for you. Alright, lots of different kinds of questions. Let's move on now to question 6. As I've changed the color of the page to give it a little more life, so let's get into this here. In this question, take pi to be 22 over 7. The diagram below shows a rectangular tank with a base of 50 by 40, which we can clearly see here, 50 by 40, that is used to store water. So the tank is used to store water, that's fine. The tank is filled with water to a depth of 15 centimeter. So this word depth here is basically talking about the height. It's not the height of the container or the tank. It's not the height of the tank, but it's the height at which the water has reached in the tank. Part A says we have to calculate the volume of the water in the tank. So what volume of water is currently in the tank? And as promised, guys, this is the first time that you may have to run to your formula sheet. So as promised, I told you that I was going to bring you back to the formula sheet if necessary. And here we are, that you could see that the volume of a prism, doesn't matter the type of prism, the formula is that V is equal to AH, where A represents the cross-sectional area and H is the perpendicular height, or in the case that it's lying down, it's the length. Alright, so we're gonna get back to that section there. So we know, based on that formula sheet, that volume is equal to the area of the cross section times the perpendicular height. So we know that volume is equal to the cross sectional area would have to be the base here. So if I were to just make a little thing here, let's just do it a little bit better. Okay, so there you can see, because the water is in the tank, you're not able to see the back, the base, the back of the tank, the base there, and you're not able to see that side. So I've just drawn a 3D perspective of what you're looking at. So what we're looking at here for the base, when they say the cross-sectional area, we have to use the base here. We could use the side, the front here, if we knew what this measurement was, this complete measurement. Alright, we could have done that, but they don't want the volume of the tank, they just want to know the volume of the water that is in the tank. So the cross-sectional area is here. That's the cross-sectional area, the base there. That's going to be 50 times 40. And since we're looking for the volume of the water that is in the tank, we have to use the height of the water, which is going to be 15 centimeter. One of the things that I want to also tell you guys to look out for is the fact that sometimes you might get a little bit tricked. Sometimes they may put on a different measurement here, unit of measurement, so they may put centimeter, centimeter and meter. Do not get tricked. Always look to see if the unit of measurements are all the same. Alright, so this is pretty easy. Just go on the calculator. 50 multiplied by 40 multiplied by 15, and that should tell me that the volume that is in the tank is 30,000 cubic centimeters of water is currently in the tank. Alright, so we're good to go on that question. Let's go to part B. The cylindrical container shown in the diagram below is used to fetch more water to fill the rectangular tank. The container, which is completely filled with water, has a radius of 20 centimeter, okay, and a height of 21. And they're saying that it is completely full. So that means if I were to take this container and to catch some water, it's going to be completely full to the brim. So what we're looking at here is the complete volume of this container here, and we're going to be putting water into it to pour into the tank. Now it says all the water in this container is added to the water in the rectangular tank. So we already know that there's 30,000 cubic centimeters of liquid already in the rectangular tank, and now some more water that is going to be in this is going to be poured into that tank on top of what we already have. Our job is to calculate the total volume of water that is now in the rectangular tank. Alright, so they didn't tell us that we need more than one. They're just expecting us to assume that just one round of this container here is going to be poured into the rectangular tank. So let's say I was to fill this with water. Alright, so the water will be up to the brim here. Okay, so it's going to be filled. We want to know what's the total amount of water that will fill this tank. So we're looking for the volume of this entire container here. So we're looking at a cylinder. Let's go back to the formula that V is equal to the area of the base times the height. And the base that we're looking at here is a circular base, so we know that the area of a circle is pi r squared. You can check your formula sheet to verify that. And then height is represented by h. Now they didn't tell us what to use pi as. Let's go back to check if they told us what to use pi as. They did. It says in this question take pi to be 22 over 7. So we're going to follow instruction. So pi is going to be 22 over 7. And they told us that the radius right here, the radius has a radius of 20 centimeters. The radius is 20 squared, and it says at a height of 21. So this is the height of the container. Alright, so we can put everything on the calculator at once. So that 22 divided by 7 multiplied by 20 squared. Just putting everything on the calculator all at once, guys. Alright, we could do it in parts if you wanted to. So 20 squared times 21, and that's going to give me a total volume of 26,400 cubic centimeter. So that's the amount of water that can fill this container. Now it says that all the water in this container is added to the water in the rectangular tank. Calculate the total volume of the water that is now in the rectangular tank. So volume of water that is now in the rectangular tank is going to be equal to the 30,000 cubic centimeter of water. Let's go back to see how we got that 30,000. I said the 30,000 was what we calculated over here. That was the 30,000. That is the current amount of water that is in the tank. Plus all of what is in here would have been a total of 26,400 cubic centimeters. That's going to be plus 26,400 cubic centimeter. And so that will give us a total of 56,400 cubic centimeters of water is currently now in the rectangular tank. Alright, so I hope that was clear for you guys. 3 marks, good marks. Let's move right along. Now we have to show that the new depth, I remember earlier we said that the depth is referring to the height of the water. Alright, the depth is the height of the water, not the height of the container. So show that the new depth, new is highlighted. Alright, the new depth of the water in the rectangular tank is 28.2 centimeters. Now there could be a couple of ways to do this, but I'm just going to stick with the one that jumps out at me most. Now let's first write down what we currently know. We know that the volume of water currently in the rectangular tank is equal to 56,400. That's what we know for sure. That's the amount of water that is currently in the tank. And we know that the area of the base of the tank is equal to length times width, because the base is a rectangle, so that's 50 by 40, and that's equal to 2000. Very good. And because it's area, it's centimeter squared. But what we don't know is the height or the depth of the water that is currently in the tank. Because we knew before pouring the water from the cylindrical tank, before pouring this amount of water into this here, the height of the water was not 1.5 but 15 centimeter. So more water was poured into the tank. We want to know how far up has it reached. So we're going to have to go back to our original formula that V is equal to the area times height, or the area of the base times height. And since we're dealing with the rectangular tank, we're going to have to use the area of the base of the rectangular tank, which is 2000. I'm going to multiply that by the height, which we don't know. We don't know what the height is. But I need to erase this V here because we know the volume. The volume is actually 56,000. Let's just create some space here, guys. So the volume is 56,400. And that's going to be equated to the area, which is 2000 times the height. Alright, and that is height, so it's just going to be in centimeter. So if I divide both sides by 2000, then I'm going to get that the height is equal to 56,400 divided by 2000. And that's going to give me an answer of exactly 28.2 centimeter. And that was actually shown. That's what was required. Alright, so that is how we go about solving that question, guys. So hopefully we're clear on that. Let's move on now to part D. The vertical height of the rectangular tank is 48. Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. Alright, this is a very interesting question and requires some level of interpretation. So let's try to have an understanding of what this is saying. What do we now know? We know that the vertical height of the rectangular tank is 48. We didn't know this from before. We knew initially, and let's just go back to that page. Initially when we started the question, we knew that the height of the water was at 15 centimeter. So that height of the water would have actually been a portion of the actual height of the container. We poured some water from this cylindrical container back into this rectangular container, and that increased the height now to 28.2. Alright, because that's what they ask us to prove here, to prove that it is 28.2. So one portion of the cylindrical tank was poured into the current water that is in the rectangular tank, and it rose the height to 28.2. What we know now, and let's zoom it up here, what we know now is that the actual height of the rectangular tank is 48. So we're going to need to find what amount of height of the tank is left. Alright, so total height of rectangular tank I'm not spelling rectangular properly, guys. So total height of rectangular tank that is left is equal to 48, which is the actual height, minus the current height that is in the tank, that's 28.2. And that's going to give me the remaining height, which is going to be, let's see here, 48 minus 28.2. And that's going to give me a remaining height of 19.8 centimeter. So that's the amount of height that is left in this tank. Now they want to find out how many more cylindrical container of water must be poured into the tank for it to be completely filled. We know that the total volume of the cylindrical tank is equal to, we had worked it out here, pi r square times h. Alright, so this is the amount of water that can be, this is the total amount of water that can be poured to fill this complete tank here. We want to know with the height that is left, alright, with the height that is left, and the amount of liquid that this tank can hold when it's filled, we want to know how much more of this tank is needed. Now we're going to work it out mathematically, but we're going to also try to have an understanding. Alright, we know that the total height of this tank is 21, but the height that is left in the rectangular tank is 19.8. Is it? Let's double check. 19.8. 19.8, that's correct. So right there and then I know that I don't need a full tank, so I know that my answer is going to be less than 1, just by looking at it, because if the height of this tank is 21 and the amount of height that is left is 19.8, I'm still going to have a little bit space left here to fill this rectangular tank. But let's get into the mathematical calculation here, guys. So I'm going to take the volume of the cylindrical tank, which is 26,000, okay, hold on, here we go, guys. Alright, good, here we go. So that's 26,000. Let's confirm what that is. 26,400. And we're going to divide that by 19. Actually, let's see here. In fact, what is better is, rather than finding the total volume of tank, we already know two very important information. We know, let's go back here, we know that the actual height of this is 21 and the actual height that is left is 19.8. So what we can do is take the height that is left, alright, so the height that is left, 19.8, and we're going to divide this by the height of the water that the cylindrical tank can hold. That's 21 centimeter. Alright, and once we divide those two, that should tell me the approximate amount of cylindrical container of water we need. So that's going to be 0.94. Alright, so that's a little bit less than 1. So we don't need a full tank, we just need 0.9 amount. Alright, you could convert this to a fraction if you wanted to have a better idea. So this is 94 divided by 100. 2 into this will go, let's see here, 45, so that's going to be 47. So 47 over 50 if you wanted a fraction. Okay, so I think that's it for that question. Alright, it was a little bit confusing there because I might have got myself into a bit of trap, but that's fine. I think we're back on track now. So the answer is going to be 0.94. We don't need a full tank. We're going to move on to the next question. Alright, so here we go, guys. Sequencing and pattern. The diagram below shows a sequence of figures made up of circles with dots. Alright, so circles with dots. Alright, fine. Each figure has one dot at the center, okay, and 4 dots on the circumference of each circle. Alright, I think I understand that. The radius of the first circle is 1 unit. Okay, so each of these spaces here, 1, 1, 1, 1, 1. So this space here is 1. So this will be 3 units. This will be 4 units. This will be 2 units, 1 unit. Okay. The radius of the first circle is 1 unit. The radius of each new circle will be 1 unit greater than the radius of the previous circle. Except for the first figure, a portion of each of the other figures is shaded. Alright, so that's fine. Let's have a look, guys. So we're looking at that diagram there. Okay, we see the radius, we see the shaded portion. Alright, so we see everything. I think I have a pretty good understanding of the information here. Let's see here. Figure 1, figure 2, figure 3, figure 4. Complete the rows in the table below for figure 5 and figure N. Alright, so let's see here the number of dots. So the first figure has 5 dots. The second figure has 9 dots. The third figure has 13 dots. The fourth figure has 17 dots. I pick up a pattern, guys. Do you see the pattern? The pattern is that for each additional figure, there is an additional 4 dots. Do you see that? The first figure has 5. We draw a second figure, so it increased to 9. So this looks like a plus 4. Let's just write it down and confirm when we're done. Then the third figure also increased from 9 to 13, so that's another plus 4. So that's also plus 4 here, 13 plus 17. So with that consistent pattern, it simply means that the next figure, which is the fifth figure, is going to be 17 plus 4, and that's going to be equal to 21. Alright, so we got that answer, that's 21. So this tells me that whatever this n represents is just going to be whatever the figure is plus 4. Alright, so could that be the case? Say it is n plus 4. We could do that. That's fine too. N plus 4. Or it looks as if it could be 4 multiplied by the actual figure. So that's 4 times the figure, and the figure is being represented by n, and we just add 1. So 4 ones is 4, plus 1 is 5, 4 twos is 8, plus 1 is 9, 4 threes is 12, plus 1 is 13, 4 fours is 16, plus 1 is 17. So both formulas work. N plus 4, 4n plus 1. I'm going to leave those 2 there, right? Both will work. Both of them will work. I think I'm gravitating towards this one simply because of the fact that they said earlier that each additional circle, or every circle, has a dot in the middle. So what this tells me is that the first circle has 4 dots plus 1. So every additional circle would have been the original 4 times an additional circle. So that's 4 times the additional circle, which is another circle. That's 4 times n plus the dot that is in the middle. That's how I'm looking at it. Alright. Another person might see it as n plus 4. It could have been just another circle plus 4. So I don't know. I think I'm gravitating towards 4n plus 1, but both will get you a consistent answer anywhere. Okay. All right. Looking at this section here that says the area of the outer, which is the largest circle. So area of the outer. The first circle has an area of pi. All right. So let's first establish what is the area of a circle. Area of circle is equal to pi r squared. Let's try to figure out how they got pi here or how they got 4 pi. So pi, so area would have been equal to, we don't need to convert pi, we just use pi as it is. And radius, they said, is 1. So that's 1 squared. So that's how they got the pi, because 1 squared is 1 times pi, and that's equal to pi. So that's how they got the pi here. Alright. 4 pi, 9 pi, 16 pi. These numbers look very familiar when I look at them. It seems as if when I square the figure, I'll get the area, because the mere fact that the radius is 1, so the radius does not affect the outcome, the result. So it's just basically squaring the figure, and we're going to get the area of the outer section. And also another thing that I've seen here, guys, is the mere fact that because the radius is 1, then each additional circle, we're just pretty much increasing the area by a square factor. So because 2 squared is 4, 3 squared is 9, 4 squared is 16, so that means 5 squared is 25. Alright? So that means what this is telling me that is that I'm going to square the figure and then multiply it by pi. So that's the formula that will get me the area of any circle. So if n was 100, it would be 100 squared times pi. So that would be 10,000 pi. Alright, that's okay. We're pretty good on that. Let's continue here. The area of the shaded region. So here we can see that the area here is pi again, and the second figure here is 3 pi, 5 pi, 7 pi. So we can see that there's an increased area for every additional figure of plus 2 pi. So that's what we know. So the first area here is pi, second here is increased by 2. So what can we do here, guys? Let's see. So let's try to figure out what this is. This is going to be very easy because you can see that we're increasing by 2. 1 pi plus 2 pi. So we're increasing by 2 pi. So this is going to actually be 9 pi. Alright. But how are we actually getting this here? We can see that 5. Okay, so this is 4 plus 3. This is 3 plus 2. This is 2 plus 1. This is 1 plus 0. Alright, so we're going to have to figure out a sensible formula to get this, because there is no consistency for each diagram. We're just increasing by 1. We're increasing by an additional pi. So what are we looking at here? Maybe, let me see here. If I multiply the figure by 2, so that would be 2n, and I attach pi to it, then all I have to do is just add something to increase it. So let me just write this down here. I'm going to multiply the figure by 2, so that's 2 times 1 times pi, so that's going to be 2 pi. But then I'm going to have to subtract something, because if I multiply each of these by 2, I'm always going to get more than what is here, so I'm going to have to subtract something. So what am I going to subtract? Let's do some trial and error here. So I'm going to say 2n times pi minus, what am I going to minus? Maybe I can minus the figure minus 1. So I can minus, let me see here, this can be a little bit tricky, guys, so just gotta try to figure out. You see, pattern and sequencing is all about finding a consistent pattern. Alright, that's why it's called pattern and sequencing. So it's not always going to be as straightforward. It requires some level of investigation. So I'm just experimenting here to see if I can find some consistency. So let me see here. Alright, so we were suggesting that we go 2n times pi. Alright, so if that happens, let's test it here. So 2 times 1 times pi, that's 2 pi. So I'm going to have to subtract something pi. I'm going to have to subtract a pi. Alright, so I'm going to subtract a pi. Maybe that will work. I don't know. It worked for this because 2 times 1, remember n represents the figure, so that's 2 times 1 is 2. 2 times pi is 2 pi. And 2 pi minus pi is pi. So we're good to go. But we have to check if it works for this. Because 2 times 2 is 4. Alright, 2 times 2 is 4. So that's 4 pi minus pi. That's going to give me 3 pi. So it works for the second figure. Let's try the third figure. 2 times 3. 2 times n, guys. 2 times n. N represents the figure. So it's 2 times n. 2 times 3 times pi. So that's 6 pi minus pi. That's 5 pi. So there we have a consistent pattern here of 2n pi minus pi. Now we can simplify this a bit further because at the moment right now we're not able to just subtract pi from 2n pi because these are two unlike terms. So we can even make this formula a bit more simplified by saying pi as a common factor and leave the 2n, and pi into pi goes 1 time. So we could say that the formula is pi open bracket 2n minus 1. A lot of you guys are probably looking at what is it that I just did to figure this out. And what I'm doing is that I'm looking for a pattern. I'm timesing numbers by 2, I'm dividing by 2, I'm subtracting, I'm adding, I'm doing some trial and error. So there's not going to be a set way that I can tell you that this is how you are to do this. It's going to require some level of knowledge. It's going to require some level and understanding of what pattern and sequencing is. So what I've just done there was that I've just investigated, I just did some trial and error, and then it just so happens to work out. Alright? So that's what I did. I tried to multiply the figure by a particular number. I tried with the smallest number, which is 2. Then once I multiplied the figure by 2 and I attach a pi to it, because everything is in terms of pi, I realized that I'm always getting one more than what is actually here. So once I realize that I'm getting one extra, I know that to get this value I'm always going to have to subtract an additional pi. And that's how I was able to come up with this formula here. Alright, this part down here is just pretty much a factorized form of the answer here, so anyone will work. Alright, guys, so that's not too bad. Let's look at this one here now. We're looking at the total length of the circumference of all circles. So the total length of circumference of all circles. So every diagram will have an additional circle. Alright, so let's try to have an understanding here. The perimeter of the first circle is 2 pi. We know that the perimeter of a circle, the circumference of a circle, is 2 pi r. However, because the circumference is equal to 2 pi r, and r is just basically 1, the radius will not affect the outcome of the circumference. But realize that every time we added an additional circle, and this additional circle will have the radius is now going to still be 1, or the radius of this circle is now going to be 2. Alright, so the radius is going to be 2 here, so let's test it out for this one. It's going to be 2 pi r, so that's 2 times pi times the radius is now 2, so that's 4 pi. So I'm getting 2 less than what is actually here. So I'm thinking that maybe I need to add 2. Alright, do you see that little investigation there? I wrote down the formula for the area, for the length, for the circumference of a circle, pardon me, and I investigated how I got this. I realized that I got this simply because the radius here was actually 1. So the 1 did not affect the circumference. Alright? I now used that very same theory and I tested it for figure 2, and I realized that the radius of the second figure is now 2. Here it is right here, 2. So now radius is now 2, pi is still pi times the constant multiplier 2, so that's equal to 4. But then that's not what is here. 4 is not there. We need an additional 2. So I'm going to hypothetically call 4 pi plus 2 my nth formula for finding the total length of the circumference of all circles. So I'm going to have to test this theory for figure 3 and figure 4. If it works for these two, then I know I'm good to go. Alright? So now let's see here that so I think I'm going to have to put an n somewhere because n would represent the figure. Alright? So the second figure, this was 4 times 2. Let's see here. I think I'm going to have to minus 2, guys, because I need to have the formula in terms of n. So I have 4 pi plus 2. That will give me just the form, but I need to know, I need to have n involved. So I'm going to think that maybe I need to 4n pi. Alright, so 4n pi, so n is the figure. Let's see here, so n is the figure. So 4 times 1 is 4. Okay. It's a little tricky, guys, little tricky because I thought I could have added 2, but if I involve n, bear with me, guys, bear with me. We just need to figure out a formula that will work. So let's see here. Let's try something else. Let's say the formula is 4n. Going to involve n pi. What will be the result if I were to implement these values right here for n? 4 times 1 is 4. Alright, so that's going to give me 4 pi. But I have 2 pi, so I have 2 more. So I'm going to have to subtract 2 pi. I'm proposing that that's my formula. Alright? Now this formula should work for figure 2, figure 3, figure 4. So let's see. Let's implement 2 here. 4 times n. In this case we're using 2 as n, so 4 2s is 8. So that's 8 pi minus 2 pi. So 8 pi is minus 2 pi will give me 6 pi. So it works for figure 2. Let's try for figure 3. If it works for this, then more than likely it will work for everything else. So let's implement 3 here for n. 4 times 3, that's 12. So that's 12 times pi, that's 12 pi. 12 pi, okay, so 4 times 3 is 12. So that's 12 pi minus 2 pi, so that's giving me 10 pi. So it's not working out for that. Alright, so it works for the first 2, but it's not working for this one. So we need to do an adjustment here, guys. What can we do here? Maybe we could try something else. This is being increased by 4. Alright, so I see another way, because this could be very complete. Let's look at another way. Notice that each of these are being increased by 4. So 2 pi, 2 plus 4, 6 pi, 6 pi plus, okay, so I see. Okay, guys. So 2 plus 4 is 6, but 6 plus 4 is 10, so it's 2 less. So there's something happening here. And 12 plus 8, so okay. So here's what I'm seeing, guys. This is 4. This is an increase of 6. This is an increase of 8. So the pattern is that each additional circle has an additional 2. Alright? So I know that this has to be 10. So this part is easy. I know that the answer here is 30 pi. but I need a formula that's going to get me my answer regardless of what figure I'm looking at. Alright, I need something consistent, guys. Let's try to figure something out here. Okay. Alright, guys, just a second, let me just figure this out. Alright, so we have to look for something that is connected to this in some way, shape, or form. So I've tried multiplying these by 4. I've tried attaching pi using n. Let's try to use a different column maybe. Let's try to use this here. Let's see here. So pi plus pi gives 2 pi. 4 pi plus 2 pi gives 6 pi. 9 pi plus 3 pi gives 12 pi. 16 pi plus 4 pi 20 pi. So I know that if I compare this column, I'm pretty much adding 1 each time. That's what I'm seeing. So let me see if I could do something with this formula here. Let's try writing down this formula here. So that's n squared pi. What could I do to this here? I know that whatever I insert for n here would be the figure, and that will give me the result that comes here. But notice that from here to here, I'm increasing by the actual figure. So I'm increasing by the actual figure, because 25 plus the actual figure is 30. 16 plus the actual figure is 20. 9 plus the actual figure is 12. Okay, I'm seeing a pattern, guys. 4 plus the actual figure is 6 pi. So maybe if I add n, but that's not going to work either, because if I just add n, I can't add a number or a constant to. Okay, so maybe if I attach pi here, then I could add that pi. This doesn't look too bad. This looks like a nice formula. Let's do a little test, guys. Alright, I must tell you, alright, I could have done this even before the video and come on here smooth like it's an easy process. But if I do that, you're never going to understand the level of thinking process that goes into a question. So I'm doing this question blindfolded, meaning that I just took out the past paper and I started to work it. So I wanted to have you see the different thoughts that has to go through a person doing math. What has to go through their minds for them to get to the answer. So it's not as easy as you all think it's going to be. Yes? So let's test this formula out. If I place 1 here and square it, I'm going to get 1 pi. So 1 pi, that's going to be pi obviously, plus 1 here, so 1 times pi is pi, so that's going to give me 2 pi. So I've got that there, that's fine. Let's test it now with figure 3. 3 goes right here, so that's 3 squared is 9, so that's 9 pi, plus 3 goes here again, so that's 3 pi, and that's going to give me 12 pi. So it works for that. One more, then we can confirm. Right? Let's try this figure here, 5. So if I put 5 here and I square it, I'm going to get 25 pi, which is what I have here, 25 pi, plus put 5 here, so that's 5 pi, 25 pi plus 5 pi, that's 30 pi. So I've done my trial and error, and I now realize that my formula at this end right here is directly connected to this third column here. Alright, so I have my formula. Alright, so this is 21, this is 9 pi, 30 pi. Alright, please ignore these numbers in between here. Okay, and this up here, these are all trial and errors or small calculations. All right, and here, so that's my answer here. This is 21. Alright, so we're good to go, guys. Alright, so those are the answers: 21, 9 pi, 30 pi, n plus 4, n squared pi, 2n pi minus pi, or pi open bracket 2n minus 1, and n squared pi plus n pi. Alright, so that's good for us there, guys. Challenging question, I have to say. How many marks was this? 7. I think it was worth it. Alright, 7 marks is a good amount of marks for a question like this. Alright, so if at any point you feel like you're a bit confused, feel free to just rewind the video and double check to see the thought process. But I wanted to show you the raw version. You could have done this beforehand and just come online, as I said before, just give you the answer as it is. But how much would that be of help to you? Alright, so hopefully if you meet another challenging question like this, you should be able to go through it yourself. Alright, perfect. So we're going to finish off with this paper here, and then we're going to upload and go on to section 8 in the next video. So here we go. Determine the value of n when the number of dots in figure n is 541. So number of dots. We have to use the number of dots column. That's evident. It's just 2 marks, so it's not that much hard work. Determine the value of n when the number of dots in figure n is 541. Do we have a number of dots column? We do. We have a number of dots column. And do we have a number of dots formula? We do. We could use 4n plus 1 or n plus 4, as I said before. So either ways work. We're going to work it both ways for you to see. So 4n plus 1 is equal to 541, and n plus 4 is equal to 541. Alright, so let's find n. So that's 4n is equal to 541 minus 1, so that's 4n is equal to 540. So if I divide both sides by 4, I'm going to get, that's 5 divided by 4, I'm going to get 135. So that would be the 135th figure. Alright? Is it, like I said, this is kind of like the same thing, so I don't think this is going to work. N plus 4 is not going to work. Alright? This is definitely not going to work. As I said before, guys, I was gravitating towards this formula here. It's 4n plus 1. It had more substance to it, because as you can see here, n plus 4 won't work, simply because yes, 4 plus 1 is 5, but 2 plus 4 is not 9, 3 plus 4 is not 13, so this is definitely not going to work. Alright, so initially I think I had written this down simply because it came at me initially, but the actual answer here is 4n plus 1. n plus 4 is just a little bit too inconsistent. Alright, so here we have it. So that's the 135th figure. It says here, write down in terms of p and pi the area of the largest circle in figure 3p. Alright, so we know that. Let's write down the formula here for area. So we're no longer using n to represent the figure, because initially if you look on the table here, that figure number is being represented by n, but in this question you're now using the figure to be represented by p. Alright, so we can just jot that down. That figure, well, we don't have to write it down, guys, we can just circle it right here. It's been represented by 3p. So n is now equal to 3p, and we're looking for what? The area of the largest circle. So let's look for a column that's dealing with area of largest circle. So area of outer largest circle, the formula for that is going to be n squared pi. area of largest circle is n squared pi. And since n is now 3, we're looking at the fact that the area of the largest circle must be 3p, because that is n, and we're going to have to square that and insert pi. Because they say that they want us to write down the answer in terms of p and pi. So we don't want n to be our answer, in our answer. We just want p and pi. So we've replaced the n with 3p. Tricky question, guys. Very, very tricky. Alright. So we're going to have to square this out. So 3 squared is 9. P squared is obviously p squared. And that's going to be pi. So our answer is now written in terms of p and pi. P and pi. So that's going to be the area of the largest circle. Alright. Using n to be represented by 3p. Alright, so that brings us to the end of this video, guys. And that brought us from questions 5b all the way to question 7. Alright, so in the next upload, guys, you are going to be going into section 2, questions 8, 9 and 10, our final upload. Alright, guys, so that's the end, as I said. So hopefully this was helpful for you. Please like the video if it's of aid to you, subscribe to the channel if you're new, and of course share this out so that other persons can benefit. Alright, all the links to my social websites such as my Instagram, you can reach out to me for live classes, personal tutoring, and any other stuff. You can check in the description below for the links to those social websites. You can contact me directly on my phone and we can do some lessons together. Alright, guys, so do take care. Until next time, Akin signing out.